involving graphs using subgraph isomorphism. While traditional methods focus on aggregating multiple time points into a single static graph, Oberoi's approach applies subgraph isomorphism to dynamic graphs, preserving the temporal details that is the evolution of graph structures over time. And this allows us to accurately detect patterns that emerge at specific moments. Moving on, let me share how Oberoi's approach is different than others. So Oberoi's solution uses a snapshot-based representation of dynamic graphs instead of aggregated models, which helps preserve the temporal sequence of events. Basically, the chronological order of snapshots enable the detection of time-sensitive patterns. Additionally, their method performs induced subgraph isomorphism, which ensures precise matching of subgraph structures. So this approach captures dynamic changes and is better suited for scenarios where timing and detailed graph relations are critical. And thirdly, let's talk about how Oberoi's solution is better than others. So Oberoi's solution was validated using real-world datasets, and its effectiveness in scenarios where temporal information was key. It showed competitive execution time while offering superior accuracy in detecting dynamic patterns, especially in time-sensitive contexts. The method outperformed aggregated models by capturing precise and exact graph structures, making it more suitable for dynamic systems like football passing networks.
Hello, Assalamu alaikum. This is my part of the code, which was actually the code execution. And first, I started with the setup of this code, which was actually a tricky part, but through some effort, I actually set up and started running the code. Then I looked up with the pattern first by looking at inputs, output, solution time, and what conclusion I came up with that the time was 0.014 1 second, and there were actually five snapshots. And the result was that these snapshots are so fast that actually it creates a dynamic video, which is the actually the study of O'Brien and his group. This dynamic setup actually distinguishes O'Brien from others, that it is these snapshots are so fast that it creates a video motion. So that's all from for my code execution part.
Okay, basically I am going to explain the summary of this paper. So, so this graphlet shows that different type of players interaction during the game, such as passes between the two players. This one indicates a single player state with no interactions, and 1 to 2. This indicates interaction between two players. Okay, the graph shows that Spain has higher usage of complex graphs that shows their teamwork and cooperation and team-based strategies, while Argentina has like single player and 1 to 2 players interaction. So they more relied on simpler and individual players. Okay, this graph shows the transition profile between the two teams. It shows the percentage. The transition percentage between pass 1 to 1 is 0.1%, and the percentage from 1 to 1 to which is self pass, that is 0.9%. Basically, it shows that Argentina has more similar passes at it covers lesser area, and it covers more area, which shows that it has different passes. So Argentina has less in trophy, and Spain has more in trophy. Okay, the concept in this graph is similar to previous one. The main difference is that it does not contain the self pass; it only contains different passes, and the perfect entropy, that is ideal, in which these all the blocks are filled, and it contains the same number of percentage in it. So that is the perfect entropy. Okay, that's about the research paper. Thank you.